All right, so today we're going to finish chapter 3. Okay, graphing absolute value functions is the last section. Okay, they're going to look kind of like a V shape. So we'll finish that up, and then we'll show you guys how you do some graphs. Okay, so first of all, on your notes, okay, you probably have a spot, I think, to fill that in. Okay. It says an absolute value function is a function that contains an absolute value expression. And Mr. Roy just asked you, how do you know something is an absolute value? Yeah, you're going to have the bars. Okay, so if I just go ahead to an example, I'll come right back to this. But if you've got something like that, you see those bars? That tells you this is an absolute value problem. Okay, so here's an example of one. Y equals absolute value x minus 2. Okay, I'm just showing you an example. Here's another one. Y equals 2 times the absolute value of x. It's another one. Anything I write that has an absolute value in it. Okay? Yeah?
The absolute value signs look like ones.
What's that?
The absolute value signs look like ones.
Look like ones that look better?
Yeah.
A little bigger. Now, what do you think the simplest absolute value function would be? This isn't the simplest one. Absolute value x minus 2. 2 times the absolute value of x, that's not the simplest one. What do you think the simplest one you could have is? Y equals what?
The answer?
Even simpler than this.
Y equals x. Y, 5, I don't know.
Y equals absolute value of just what?
Itself.
Think of what letter has to be on the other side.
Y.
Nope, only one letter on the other side.
X, Y.
What letter is on the right?
Y.
No, left is y.
X.
Right is x.
X.
So what could you put on the right-hand side that would be simpler than what I just circled?
Y equals U. I'm so confused. Is it like a fraction?
Nope. Here's another one. Okay, I'm going to keep giving you ones that are not as simple as they could be.
Is it just X, 1?
There's another absolute value problem, but that one, still, there's some extra stuff in it. You could simplify it. Yeah. Okay, the simplest one you could have is right here. Y equals absolute value x. Okay, and the simplest function, okay, they call that the parent function. The parent function means it's the simplest one you can have.
So in the blank on your sheet, you want to write parent function is y equals absolute value of x.
And the way you can kind of remember that it's the parent function, right? We come from our parents. So every function here comes from the parents, right? This one could be, you put in a minus 2. It's almost the same thing. All you did was put in a minus 2. So it's a little different, but that's the function that it comes from, right?
So Mr. Hager, correct me if I'm wrong, but we're going to, sometimes when we're graphing these, aren't we going to compare it to the parent function?
Yes.
Yeah.
So we might look at this and then say, how does
Guys,
it?
that's why we're mentioning the parent function, because we're going to graph these, we're going to have to compare what it looks like to the parent function. That's why we're mentioning it.
Okay, so an absolute value function has a point in it, okay, a special point called a vertex. Lines don't have a vertex in them. So this is something new. And we've got a picture to show you what a vertex is.
Does anybody anybody ever heard that word before, vertex?
Yeah, like when we were doing, I don't know, is it like before written me?
Yes, exactly. Like, and Josh was saying too, geometry, right? It's like for like an angle, right? Angle looks like this. This right here. I think that's what you were saying, you were saying like the middle, right? Perfect. That's what it is. All right. It's the same thing here. Vertex is like the middle. All right.
So vertex is right where the point of that V is.
Yeah. So it's like we just took this and kind of tilted it and put it here. There's a lot of ways to think of it. The middle where it opens up, where it makes the V anything like that.
Now, sometimes you can have an absolute value function that looks like this. Okay, it's flipped upside down. That's still the vertex. Okay? I don't think we're going to get into too many that are flipped upside down. We are going to do some things with this V shape, okay? But we're not going to flip it upside down, I don't think. All right, so we've talked a little bit about domain and range. Okay? Domain has to do with what letter? X or Y? Yep, X. And range, that's the Y. So if you're looking at a graph, domain is how far to the left and how far to the right your graph goes.
Mr. Jacob, can you put above that domain, can you put left and right?
Yep, or even arrows.
Yeah.
So domain is left and right. Range, if you're looking at a graph, is up and down.
Yeah, and guys, we sort of did this when back a few weeks ago when we had identified domain and range. We had to say it was from a certain point. Like we picked like the highest y coordinate and the lowest y coordinate. And so that was the area we had. Same kind of thing going on here.
Now I put arrows on that because I don't want you to think that it stops there. Absolute value, this V shape, it just keeps going. But obviously on my screen, I can only show you so much. So how far to the left does this graph go? What do you think? If you look at that, Aiden, how far to the left?
Think about what Ms. Hager just said, right? He said that line can go on forever.
So what's it heading towards if it keeps going to the left? Negative what? What does it head towards? Negative, not negative 100, not negative 1,000, not negative 1,000,000,
And
even
same
further.
thing goes on forever. See, look at that word, that means it goes on forever.
Negative infinity.
Yeah, exactly. The domain, it goes from negative infinity all the way to, what about it as it heads to the right? Positive infinity. So one way you can write it is just like this. That's the domain. If you don't want to write it like that, you can write out a sentence. It's a little longer, but you could say the domain is all real numbers.
Mr. Hager, what would you prefer?
Either one. Yep. Either way you want to do it. These both mean all real numbers. All right, so that's the domain. It goes to the left forever and it goes to the right forever. Now, how about the range? Does this graph go up forever? Look at those arrows. Does it go up forever? Vanessa? So you think it stops?
Well, it's going up, it just has one point.
Is it going up?
Oh, yeah.
It's going up and to the right and up and to the left, but it's still going up forever. Is it going down forever?
No.
No. Absolute value functions can either go up forever, or if it was flipped over like this, it could go down forever, but it can't do both at the same time. It's one or the other. So this one, did we say up forever or down forever? Up forever. So if it doesn't go down forever, there must be a value that's the lowest. What's the lowest value that this function hits?
0.
Yeah, it hits 0 right there. Okay? So we could say the range is all numbers that go from 0 to infinity. So there's a couple ways we can write it. I think the simplest way is just say the range in this problem is all numbers greater than or equal to 0. Or you could write that out. All numbers, I think this is longer, but greater than or equal to 0. If you prefer sentences, that's how you can do it. Okay, so any question on the domain and range there?
So you couldn't put like a little 0, like a little dash, or so 0 through infinity?
If you wanted to write it differently, you could do it like this, but I didn't get into that.
Okay,
Yeah.
all right.
Okay.
So
This technically is another way you can do
Either
it.
one of those ways.
Yeah, I would probably stick with one of these two.
Yeah.
I really don't want to get into explaining why
You
I,
guys, for that first
Put
one,
a
you just gotta
bracket
make
there.
sure you know what your signs mean, that's all, okay?
okay, so this, just ignore that. Stick with one of the two ways I showed you. Great, so any questions on that? So now, if you took this V shape, let me just trace over it in red. Let's say I move it to the left, like that. Did I change the domain? What do you think?
No.
What was the domain before? No, range has something to do with zero. Yeah, the domain, it went left forever and went right forever. If you take something that goes on forever and slide it to the right a little bit, does it still go on forever in each direction? Yeah, so that didn't change the domain at all. How about, did it change the range? What's the lowest value that it hits as you start heading down? How low does this red graph go? It's the lowest value it hits. Remember, on the y-axis. It hits 0. Okay, it hits it right here. Does it go any lower than 0? Nope. So did I change the range? By sliding it left and right? No. The range was all numbers from 0 and up. It's still all numbers 0 and up. So what does that mean about moving an absolute value function to the left or to the right? It doesn't what? It doesn't change the domain or the range. Now, what if I did something like that? Does it still go forever left and right? Yes. But is 0 the lowest value that it ever hits? No, it goes lower than that. Now it goes down to -8. That's the lowest it goes. So moving it up and down, that does have an effect on the range. So we'll talk more about that. Okay? We can also take a graph and we can go like this. Okay, what did I just do? Let me try it down here. Oh, there we go. What did I do now? Yeah, I made it thinner. Now, even though I made it thinner, is it still going to go left and right forever? Yeah, it's not quite going as fast, but this side is still going to head up and to the left. This other side still heads up and to the right. Okay, so that made it thinner. I could also stretch it out. Is it still going to head to the left and the right forever? Yeah. So we can take this V shape and we can do 4 basic things to it. We can move it up and down. We can move it left and right. We can stretch it up and down like that. And we can stretch it or compress it left and right. Okay, so we'll look a little bit at those, but we're going to focus on most of them that just move it up and down or move it left and right. Okay, not too much with the stretches because that gets a little complicated. All right, so to graph an absolute value function, you need 5 points. Okay, we're going to find 5 points. And what we're going to do is create a table. Okay, do they have an outline of the steps, Mr. Roy?
They have to write them in this table. They don't have to write, we're going to create a table, but they have to write the steps.
All right, step 1. You're going to set what's inside the absolute value bars equal to 0.
Remember guys, there's a little bit more to this. And what we'll do guys is there's space for an example on there. We'll talk about the step and then we'll show you an example. We're going to do a step-by-step example too as we go through this. So you'll have the words, right, the description of each step, and you'll also have a visual so you can see what happens.
Okay, so step 1 says set what is inside the bars equal to 0. What I'm circling in blue right there, that's what's inside the bars, x minus 2. Okay, so any question about what I mean by that? Inside the bars? If there's something on the outside of the bars, don't worry about it. just leave it. Just ignore it. Okay, so set what's inside the bars
Well, you
equal
just
to
did right
0.
there, that plus 2, that wouldn't matter, and then they would just do x minus 2 equals 0.
Mhm.
They wouldn't worry about the plus 2 or anything like that.
No.
Okay.
That number that I put on the outside, whatever it is, it will have an effect on the final answer, but it has no effect on step 1. Okay. All right, so set what's
This is
inside the
a little bit
bars.
different when we solved absolute value equations and inequalities. What was inside the absolute value had to be by itself. Remember we said there can be nothing else around it?
Yeah.
We don't have to- So guys, what we're getting at is, you don't have to worry about that here. If there's something outside of it, you don't gotta worry about it in this step. All right, all we're worried about is what's inside the bars, and we'll make that equal to 0. What's outside does not matter, we'll just ignore it in this step.
So I'm going to do what Mr. Roy just said. Take what's inside the bars and set it equal to 0. Not the bars themselves, just what's inside. Now, it doesn't only say to set it equal to 0, it says set it equal to 0 and,
What's the second sentence say?
or the end of the first sentence, and solve.
Oh,
Okay, so how do I solve that equation? Add 2 to both sides. So what does x equal? 2. Okay, we're just going to circle that number, we're going to remember it,
we're gonna need that in the next step.
and we're going to use that number in our next step when we start to make our table. Okay, so remember, does anyone remember how many numbers did I say we're going to put in the table?
Guys, when we set up tables before, right? We've done different things with graphing and stuff like that. How many numbers, what numbers did we use? Anybody remember? What were the numbers we said? If you're gonna set up a table, and for the x values, what we always use? Josh? -2 to 2, so -2, -1, 0, 1, 2, right? +1 and +2. How many numbers? 5. Same thing here, but listen to me. The -2, get that out of your mind. We're not doing that for these. All right, when you solve and get this, all right, this is gonna, when we go on to that next part and set up our table, all right, that's gonna be our middle term. All right, so that's gonna be our middle term. That means there'll be 2 x values above it, there'll be 2 x values below it, right? So the -2, -1, 0, 1, 2, we're not worried about that, right? Once we solve for this, that's going to be our middle term. Mr. Hager, he kind of drew it up, all right? We're going to show you in the next step how it works.
All right, so in our table, that 2 will be the middle value. You need to pick 2 numbers smaller than it, so we'll go 1 smaller, and then another 1 smaller. And then we need to go 2 numbers bigger. So, actually, you know what? I'll hold off on writing them in, and I'll ask you for them in the next step. Okay, so you need these additional x values, because without them, you can't make your V shape. Okay, these are a little more complicated than lines, so we need some extra points. Right, so we're going to pick the 2 x values that are smaller than 2, and then 2 x values that are bigger. And if you do this, you're going to get a nice V shape. Okay. What Mr. Roy and I want you to avoid is in case something like this happened. If you pick 5 points like that, you only have one side of your
It
V.
doesn't have to be.
Right? You're missing over here. So the way we're showing you how to do it, you're basically going to get this every time. Okay? You'll get your full V shape. All right, so from step 1, what was my middle x value? Liam? What was my middle x value? 2. So I'm going to put that in my table, and if it was gridded, I would put that as the middle value.
And guys, I mean, we put the X and Y on this part so you can see it, but on homework, on the rest of them that we do, all the rest of the examples we do in class, on the test, on Thursday, you're gonna have to draw the table yourself. So whether you wanna draw just the two lines with X and Y, one going down, one going across, you wanna draw individual lines, you can keep it organized, it's entirely up to you. But we just did, we put the chart on this one, this so we can see it, so when we wanted to show you guys how it works.
Does anybody know why I like the table like this? I call this a vertical table rather than horizontal. Anyone know why I like this one better? Because if you start writing this out, what you're going to get here, 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 and here, you're going to get coordinates. And it's like if they're in a table like that, they're already lined up to be coordinates. Okay, some people like to do it like this. Okay, put your X's and Y's and make it horizontal. You can, but then you're not getting coordinates lined up horizontally. Okay, this will just give us 2, comma, and we'll put a number right there. Okay? All right, so what's a number that's smaller than 2? Exactly, 1 smaller. 1, and now 1 smaller than that. 0. Now give me a number bigger than 2, just 1 bigger, and 1 bigger. Okay, now is that going to be your table every time? No, because this number is going to change. Okay, in step 1, we figured that number out. It can change in every problem. It could be a negative number, it could be a positive. And now, once we have these X values, what do you think you have to do next? You only had half a table. What's missing in that table? I'm missing all the Y's, so that's step 3. Calculate the Y's. And how are we going to do that? Well, if we go back up, we have a formula right here. This formula tells us how to find the Y values.
So when, what was you guys written down?
You might be thinking there's not a Y here in this formula. Well, yes, there is. We'll try to remind you of where the Y is in this formula. Does anybody remember Mr. Roy and I said if you don't like this, you can just change it to a Y? Yeah? Yeah, this M of X, that is really Y. So if you don't like this box and this what's in the box, write it like this instead. That's exactly the same thing.
Now, guys, when we do this, when we solve each Y value, how many problems are we going to have? Anybody know? Yeah, like Shannon just said, we're going to have 5 because we have 5 X values. And we're going to plug in X every single time. Plug it in, plug it in, plug it in, plug it in, plug it in. Right, we're going to plug it in 5. So we'll have 5 separate problems. Now, it's up to you. If you can just say, you know in your head, like 0 minus 2, you can see that in your head, all right, and do it, that's fine. My suggestion, and I think Mr. Hager will probably suggest the same thing, you're probably going to want to write it out. We'll make sure on tests and on homework and stuff like that, you'll have enough room to do that.
Okay, so what's the first X value that I plug in my table? 0.
Yeah.
What's 0 minus 2? And now what's the answer for the absolute value of negative 2? 2.
Now, guys, notice when we did this before, all right, we did absolute value. We made the absolute value disappear, right? We said we wanted to break it out. We don't want to do that on these, right? The absolute value is going to stay. So even if you get a negative inside the absolute value, it'll obviously change to a positive. We can never have an absolute value that's a negative.
Okay, what's the next x value we plug in? Yep, 1 minus 2. What's 1 minus 2? And what's the absolute value of negative 1? 1. Okay, so we got that. Do I have enough space? Sure. What's the next x value? 2. So 2 minus 2 gives me how much? And what's the absolute value of 0? 0. All right. Next x value. 3. Absolute value of 3 minus 2. What's 3 take away 2? 1. What's the absolute value of 1? 1. Okay, I'm going to ask you to look for a pattern, too, in the y values in a second. Last x value. 4. What's 4 minus 2? And absolute value of 2? 2. What do you notice about the y values? It's what? Yeah. If you do this correctly, your y values should be the same whether you read them forwards or backwards. Okay? Always. That should always happen. Okay, these y values should be the same.
So, Mr. Hager, could you say that once you get the first two values, well, actually, I should say the first three, for those last two, could you just match it up?
We should be able to. I'm just trying to think of an example where that doesn't work.
Okay.
I don't think we do any that are as complicated where that could happen. Yeah.
So guys, what I'm saying is, once you get these, I mean, obviously the middle one will be different, all right, but once you get these first two, you know that should be 1, you know that should be 2, all right? So these two match up, these two match up. Once you do this one and this one, it should match up to that one and that one. You can just write your answer there. If you don't want to do all the work, all right, you can just do the first 3, all right? Because then, like I said, these will match up, all right? The middle two will match up. Well, the inside will match up. The outside will match up.
Yeah, that should always work. No. Okay, and then step 4 is to graph it. Okay, so take those points that we have, put them on the graph.
Now, when we graph this, what should happen? Jordy, you think you know? When we graph this, what should it look like? You know what we did at the beginning. What letter should it look like? Huh?
What shape does the graph look like? Yeah, what is that? What letter?
That works.
Oh, V.
Yeah.
V.
Well, I have a triangle.
All right, so I've got the point 0, 0, 2. We've got 1, 1. Okay, we've got 2, 0. Okay, notice what's happening. I think I'm starting to see my V. I think it's going to turn right here. 3, 1, and 4, 2. Okay, and then just make your V shape. Okay, what's the domain of that? How far to the left and to the right does it go? Infinity to negative infinity. So you can write that, or what could you write it in words? You could write all real numbers. I'm thinking people maybe are more comfortable with that. And now the range, is the range go down forever? No. So then that means it has a lowest value, but does it go up forever? Yes. These V shapes, they just keep going. So what is my range here? What's the lowest value? What's the highest value?
0 to 4.
Well, it goes above 4.
0 to 10.
It goes above that.
0 to infinity.
0 to infinity, yes. So for the range, you could say it's all values greater than or equal, because it does hit 0 right there. Greater than or equal to 0. Yeah. Okay. Any questions on that?
I'm teaching in a college.
Yeah, it's not too hard. Now, where's the original V shape? The parent function. What's the difference between this one and the parent function? Just a small difference in where the V shape is. Okay, if you need to see both, let me copy and let me see if I can put it right next to it. Okay, anybody tell the difference between the two V shapes? Well, they both go up forever.
Yeah, the wire thing. Wire V. Wire V.
Well, that could just be the screen is a little stretched out.
It's centered on the 0.
Yeah, where's the vertex of this one in blue? It's at the origin. Where's the vertex of the black one?
On choose one. No, I can't.
It's in the orange.
No, it's not on the origin.
That one's in the orange. That's the parent.
Dos, amigo.
Yeah, it's on 2, right? So where did that 2 come from? Came from right there. So this number is a hint at where the vertex is going to be. Okay?
Wait, always will be like that?
It's a hint at where it'll be, yeah. So the vertex in this problem is at 2. Okay? Where do you think the vertex might be in this one? Kind of a hint. It's going to have something to do with 3. Whether it's 3 on the x or 3 on the y, we might not know that yet. But it is going to have something to do with 3.
We do that one now.
Yep, I'm going to do it right now, as soon as I put it on the screen. Okay, so they want us to graph the function. So we got to make our table first. Then compare our picture to the original. Okay? And if you need the original, I think I still have it. I can make a small copy of it. That's the original. Okay, I'll just keep that off to the side. All right, who can tell me when I'm making my table, what's the first thing I do? Step 1.
Draw the actual table.
Okay, I can make the table, but I need numbers to put in it. So how do I do that? Okay, here's my table. Yep,
You have to take everything that's inside the absolute value bars and set it to 0.
perfect. What's inside the absolute value bars here? Just an x. This is the easiest kind you can have. And what did you say to set it equal to?
0.
0. Now to solve that means get x by itself. Is x by itself? Then we're already done it. Okay, we don't have to do anything to solve it. So this, where does this go in my table?
And center.
In where?
Center.
Yeah, for which column, x or y?
X.
Yeah, because it says x. Now I need 2 values smaller and larger. Somebody give me 2 values smaller than 0.
1 and negative 1 and negative 2.
Yep, and 2 values larger.
1 and
1 and 2.
But it's absolute value, I thought you could have.
Well, now we're going to plug all these numbers in one at a time. So we're not going to have a negative once we plug it in.
And so we're solving for y. All right? So it's okay if the x is a negative.
Okay, so y equals, what's the first x value? Negative 2 plus how much?
3.
Plus 3. What's the absolute value of negative 2? 2. What's 2 plus 3?
5.
5.
Ooh, simple math.
Okay. I won't write them all out, but let's do at least what I can fit. What's my next x value? What's going to go in the bars next? Negative 1. What's the absolute value of negative 1? 1. 1 plus 3? 4. Anyone want me to write out one more? No? Okay. Now plug in 0. What's the absolute value of 0?
0.
What's 0 plus 3?
3.
Great. Now plug in 1. Absolute value of 1?
Oh, 1.
1. And then plus 3, there's your 4. And then absolute value of 2?
5. Well, 5.
Plus 3 is 5. Okay? So if those first and last match up and the second to last and the second one match up, then you did it right. Okay, now I got my table, but what do I have to do with that? Why did I make a table? Because I just like making tables? Yeah, to help me graph it.
Easier.
Yeah, so now we're going to graph negative 2, 5. Right, and what should this look like as I start to do it? Should be a V shape. Let's see what happens. Negative 1, 4. Okay, just put it right over your number. 0, 3. Now this should be it. It should start turning at this point. 1, 4, and 2, 5. Did we get a V shape?
Nope.
No? All right. Now, compare that to this one. It says compare this graph to the original. What's the difference between the one in black and the one in blue? I think they're pretty much the same width. Okay, if it's not, it's just because I drew it, a little bit off. But now they're the same width.
The graph you just drew is higher up on the y-axis than the original one, the mother one.
Okay, keep going with that. Explain more with that, Bay.
The one on the left is a little bit taller, and a higher number.
What's a higher number? What do we have a name for what you're talking about?
What do we call the middle?
Negative number.
Are you talking about this? What is? Anybody help Bay out? What is that? It's the vertex. Okay, so the vertex of this one has been shifted. How? Compare this to that. What's the difference? It went up how many?
2.
3. Okay, it went up 3. So the first thing you have to do when they ask you to describe the difference, you have to tell me 2 things. First thing, what direction did it move? Second thing, how much? Don't just say it went up. If you say it went up, I'll give you half. If you say it went up 3, I'll give you full credit. All right, so compare each graph to the original. Yep, so to compare it, and I'll do domain and range in a second. The new graph has been shifted up 3. Okay, so this one moved up. What direction did the last one move? Did it move up and down? How did the last one move? It moved, Shannon? Yeah, the last one, it moved to the right. Does anybody notice a difference between, see if I can put them on the board at the same time? Let's see. This problem and this problem. One of them moved left and right, one of them moved up and down. Does anybody see the difference? Why one did one and one did the other? Look at the number. That's the key. Look at where the number is. Where is the number in this one? Where is the number in this one? Josh?
2 is -3.
Focus on where. Not the sign of the number. Focus on where.
So the -2 is in the...
Yes. In the first one, the number is inside the bars. Okay? When the number is inside the bars, that's going to cause something to happen. When the number is outside the bars, that's going to cause something different. Okay? So you might start to kind of notice a pattern here, whether we move left and right or up and down. Okay? Okay, so what is my domain? Somebody tell me my domain here. Okay, and again, we'll just focus on that one in black. Well, Emma, what's my domain?
It's the same as everyone we've done so far.
Yeah, this domain is going to go to the left and to the right forever. So all real numbers. You shouldn't even think about when they ask you domain. It's always the same for this type of graph. How about my range? Is my range all real numbers?
Yes.
No.
Does it go down forever? Then it's not all real numbers.
It's all fake.
Yes, it's all fake. Y is greater than or equal to 3. Yes. Okay. You will hit any number from 3 and up. Okay. You won't hit numbers below 3. Okay. Any questions on that one? Okay. Anybody need to copy anything else here? All right, so what was that? That was example 1. I think we go to example 4 today, so we have three more. Does anybody, before we do anything here, recognize what might happen? Where is the 1? Inside the bars or outside? It's outside. So did anybody see that pattern when it's outside the bars? How does it move the V shape? Left and right? Or up and down? This is going to move it up and down. Anybody have a guess how many units it's going to move it? One unit, but it has a negative in front. So what do you think is going to happen? This is going to take the original V shape and move it down 1. Okay? So if you notice that pattern, I could compare the graph without even making the table. It's going to move it down 1. That's why it's a negative 1. If it was a plus 2, it would move it up 2. Okay, so there's a really nice pattern to this. All right. Easley's, can you tell me my first step? I want to try to make this table. Not sure, Trenton, can you help her out?
Put 0 in the graph.
I like the idea of something with 0, but not plugging it in for x. But something with 0 and something with the x, but don't plug 0 in for x.
You made 0 equal to y.
No, something with x. It is something with x, not y.
X. You made 0 equal to x.
Yeah, take what's inside the bars. Okay? What's inside the bars? Just an x. Set it equal to 0. Now, it's not always going to be that easy. Okay? Eventually, you're going to have something where it's like this. You've got more stuff inside. Don't worry, I'm going back. Now, where does that 0 go in my table? Right in the middle. Number smaller than 0. Another number.
-2.
Bigger. Bigger.
2.
2. Now, I got all my x's. What do I have to get in my table next? Yeah, I got to get the y's. Ashley, can you tell me how do I get this first y value? Y equals, fill in -2. Maggie, what's the absolute value of -2? 2, good. 2 minus 1. Vanessa?
3.
That's 2 plus 1.
Oh, 3 minus 1. 2 minus 1 is 1.
Yes. 2 minus 1 gives me 1. Okay, let's do the pattern this time. Let's just do the first 3. And actually, can anybody tell me what else is going to be 1 in this table?
The bottom one.
Yeah, let's just fill that in right now. Okay, so we got that one. Let's do -1. Y equals, what am I filling in? -1 minus 1. What's the absolute value of -1?
Also be 0.
And 1 take away 1?
0.
0. So what other place can I put a 0 in my table?
On the 1.
Right there. Okay. Last thing I have to fill in for x is
0.
0. What's the absolute value of 0?
0.
What's 0 minus 1?
-1.
-1. This
That's a lot of ones.
should still be a V shape. If it's not a V shape, then we did something wrong. All right, so -2, 1. -1, 0. 0, -1. So far, so good. Now I'm hoping it starts to take that turn. 1, 0. 2, 1. Does it look like I have a V shape? Yep. Draw your V. Now, how far left and right does this graph go? What's the domain? Now, real numbers. We're getting it.
Always.
What about the range?
Y is
0.
Not greater than or equal to 0. It goes a little lower than that.
-1.
Yep. It goes from -1 up forever. Now, how would you describe this graph compared to the original? Oops.
Lower.
So this graph shifted
Down.
down how many?
1.
Down 1. Okay, so write that. New graph shifted down 1 unit.
Guys, the first 3 you do in the homework tonight are gonna be just like this. But sometimes we might just have you graph it and describe the domain and range. Sometimes you might have to compare it to the original and also give the domain and range.
Now, each one of these graphs that we've done so far, they only did one thing. Shift down, shift left, shift right, shift up. Just one thing at a time. How many things are happening in this graph? A couple? How many is a couple? 2. This 2 is going to have something to do with shifting left and right. This -4 is going to have something to do with shifting up and down. Okay? But if you're not sure, I'm not sure which way is which, how can you figure out how to graph it? What do we always do to make a graph? Make a table. Okay, make your table first.
But guys, notice the directions on this one, all right? You've got to pay attention because you may do more work than you need to. We're only graphing. We don't have to compare it. We're only graphing this one and describing the domain and range. We don't have to write the sentence. We only write the sentence when it asks to compare.
Okay, how do I get that middle value in my table? Well, I don't have sides yet. I gotta create something, but you're on the right idea. Yeah?
You have to set everything inside the absolute value bars to 0.
Set this equal to 0.
Oh, and then you minus 2.
Now you minus 2 from both sides. So we get x equals -2. Where does that go in my table? Right in the middle. Give me a value smaller.
Smaller?
Smaller.
-1.
Nope, that's bigger.
Oh, -3, -4.
And then bigger. You already said -1. Give me one more.
0.
0. All right. Now we're going to plug each number in. Let's start with -4. What's -4 plus 2? -2. And the absolute value of -2? And what's 2 take away 4?
2.
-2. Okay, let's write the next one down. Let's plug in -3. Absolute value of -3 plus 2, take away 4. What's -3 plus 2? -1. What's the absolute value of -1? 1. And what's 1 take away 4? -3. Now, where else am I going to see -3? What row? Right next to -1. And where am I going to see -2? Okay, I only need one more value I need to find. Close. What's -2 plus 2?
0.
0. Absolute value of 0.
0.
But what about when you take away 4?
-4.
-4. So let's graph that and see where the V shape is. This one's going to move in a couple directions at the same time. So -4, -2. Let's see, -3, -3, -2, -4 should be about right there. -1, what is it? -3 and 0, -2. Okay, quick vocabulary review. What is that point called? Vertex? What's that point called?
Your y-intercept.
Very good. It's my y-intercept. Yeah.
I deserve candy. Just kidding.
Okay, what's my domain? All real numbers. What about my range? What's the lowest value that I hit?
Hager, Casey.
-4, and then what's the highest?
0.
Nope, I go higher than 0.
Oh,
I just keep going, right? Any number that's bigger than -4 or equal.
So guys, you're always gonna get that y, when you do the range, you're always gonna do that y greater than or equal to, always.
Not always. Not always.
Scary looking.
All right, last problem.
I'm screwed.
You're like, I'm confused everyone. Oh, because.
Okay, any questions before we do our last one? Okay, up until now, how have all of these graphs looked?
Like this.
They look like a V shape.
Oh, it's gonna be like that.
Now, what did I say you could do with the V shape sometimes?
You could move
You
it.
could flip it upside down.
Now it's like an egg.
It will never end up sideways. Nope.
Wait, like this? It's like
Now, when the problems have, okay guys, when the problems have a lot of numbers like this in it, Mr. Roy and I are not going to have you do anything more than just graph it. Okay, you're not going to have to do the fancy compare it to the original.
We got two things going on the outside. All right, you have
Three things.
Yeah, you got three things going on here. Because remember, it's going to move a couple different ways. So it's going to be hard to describe that. We're not
And
gonna-
remember you guys said to me how a graph can like stretch, get skinnier or narrower? This 2 and this negative is going to cause it to get skinnier or stretch it,
Yeah,
okay?
we're not gonna make you guys describe that.
But you don't really have to worry, you just have to follow the same steps. Okay, so what's my first step?
You gotta find the X.
Find that middle x value.
Yes.
How do I do it?
Put the stuff inside the bars.
Yeah, you can ignore everything that's outside the bars, take what's inside the bars,
And make it 0.
make it 0. How do I solve that?
You subtract 3.
Careful, not subtract 3,
Oh, add 3.
add 3. Add 3. So what's x?
3.
3. Okay. Now give me a value smaller than 3. Another value.
1.
Uno,
Okay, bigger than 3.
4,
And
5.
one more, 5.
No,
Now, what do we do with each one of those numbers?
5.0.
How about Ashley? What are we going to do with each one of these numbers? Yeah, we're going to plug them in for x. So Vanessa, what's my first number I plug in?
Plug in the 1.
Yep. Can you tell me what it'll look like for the formula?
-2. X minus, no, 1 minus, like, 1 minus 3 plus 1.
Hey, now just do out that arithmetic. What's 1 minus 3? -2. Now, what's the absolute value of -2? 2. So just be careful with your arithmetic. What's -2 times 2? -4. And what's -4 plus 1? Negative what? -3.
That's it.
Yes, I am.
Sure.
Positive.
Okay, next,
This is 4.
what's the next number I plug in? 2. So change x to 2. So what am I going to have there? -2.
Oh,
2 minus 3. Close your absolute value. Plus 1. Hey, now do out that arithmetic. Derek, can you help me with that? What's 2 minus 3? -1. Okay, Vanessa, what's the absolute value of -1?
1.
1. Emma, what's -2 times 1? 2. Does everybody agree before I keep going? What's -2 times 1? And what's -2 plus 1? -1. Okay, you gotta be careful with our arithmetic here. All right. Where else are we going to see this -1?
4.
Right here? And what about the -3?
5.
Antonio,
Yes.
what's the last value for x I got to plug in?
-2.
Nope, we don't even have -2 as an x. Our x's are 1 through 5.
3.
3.
Oh, 3.
That's the one we're missing. Well, Kaylee, go ahead. What's 3 minus 3?
-4.
0.
I like 0. What's 0 times -2?
0 times -2 is 0.
0. And what's 0 plus 1? 1. Okay, so that time you had to do a little more arithmetic, but if you need it, you can always use your calculator. Okay, graph your points and see what this one looks like. 1, -3, 2, -1, 3, 1. We've got 4, -1, and then 5, -3. What's a little different about this one? It's upside down. Is it still a V shape?
It is, it's just back upside down.
Yeah, it's
That's all.
just flipped. Okay. So what is my domain?
The domain is all negative real numbers? All real numbers.
It's still all real numbers. Okay. Domain is how far to the left and the right. This graph is going to head to the left forever, and it's still going to head to the right forever. Okay, so all real numbers.
And then y, the range to 1 is y is less than or equal to 1.
Yes, perfect. So this time your range is less than. Okay, so earlier we were saying you're always going to put greater than. You might not always. In this case, it's less than. Jody, what are we putting in this case for an inequality? What's my inequality here?
Oh, I got you. It's
Somebody help Jody with the range. Guys, please don't pack up. Thank you. We still have homework to give you. Remind me, somebody, Vanessa, you said the range. What's the range?
I said y is less than or equal to negative 1.
Less than or equal to 1. All right, so reminders for the rest of the week. Test on Thursday. So that means my extra help is going to be the same day as Mr. Roy.
That'll be after Wednesday
I will be after Wednesday as well.
and today.
Friday, half day. We'll have class like 10 to 11, something like that. And your homework tonight is a worksheet.